Hi, my name is Harun Rashid and this is Z11 Part A. Today I will be talking about N-type semiconductors, P-type semiconductors, PN junction, depletion layer, barrier potential, forward bias diode and reverse bias diode, and the effect of forward bias diode. So, an N-type semiconductor is a type of material used in electronics. It is made by adding an impurity to a pure semiconductor such as silicon or germanium. The impurities used may be phosphorus, arsenic, or some other chemical element. These are called donor impurities. This is because they provide extra electrons to a semiconductor. The purpose of doing this is to make more charge carriers, or electron wires, available in the material for conduction. The final material is a lot more conductive than the original silicon or germanium. P-type semiconductors. P-type semiconductors are created by doping an intrinsic semiconductor with an electron acceptor element during manufacture. In P-type semiconductors, holes are the majority carriers and electrons are the minority carriers. A common P-type dopant for a silicon is boron or gallium. A p-n junction is when a piece of silicon is doped with p-type at one end and n-type at the other end. Where they meet, a p-n junction is formed. Depletion layer. Depletion layer is where the negative electrons migrate to the positive side. To fill up the holes, this will form a layer of negative charge in the anode side by the p-n junction, and a layer of positive charge will form in the cathode side by the p-n junction. Barrier potential. Barrier potential is when the forces of the opposite charges form an electric field in the depletion region. The electric field then becomes a barrier for the free electrons in the N region, so the energy must be expanded and a voltage has to be applied to allow the electrons to move through the electric field. The potential difference is known as barrier potential. It is usually between 0.7 volts for silicon and 0.3 volts for germanium at 25 degrees Celsius. Forward bias diode. A forward bias diode allows current to flow through the p-n junction. To bias a diode, an externally applied DC voltage is placed across the device. As the externally applied forward bias voltage is increased, the depletion layer is increasingly reduced. The effect of forward bias on depletion region is with no forward bias, the barrier potential of the depletion region is about 0.7 volts. As the externally forward bias voltage is increased, the depletion layer is increasingly reduced. When the applied voltage is bigger than 0.7 volts, the depletion region is closed and the diode conducts a current. Reverse bias diode. To reverse bias a diode, DC voltage is applied across it in the opposite direction. This causes the width of the depletion layer to widen without any current passing through. The reverse bias across a diode cannot be increased without limit. If the external reverse bias voltage is increased to a value called the breakdown voltage, then the reverse current drastically increases. And this is how a current flows through a p-n junction. Thank you very much.